Okay, so I'm going to talk a little bit about dilations today, so that way when we get to class we can practice them so we can get comfortable with them. A dilation is when you take in some kind of image and you either increase it in size or decrease it in size. And in order to increase or decrease it, you're going to multiply its original image's characteristics, say the side lengths or the points on a graph, by a scale factor. And so the two different rules that you need to make sure you know are that if you are dilating it on the center, if the dilation is at the center of the origin, if the dilation's center is at the origin, then you just multiply the x and the y by k, where k is the scale factor. If the center is at some other point other than 0, 0, so a, b, where a and b are not 0, then you're going to take the x value and subtract a from it and multiply that by the scale factor, and then you're going to add a back to it. And then you're going to do the same thing with b. Take your x, subtract b from that, multiply that by the scale factor k, and then add b to it again. And that should be a y, not an x. So the k is the scale factor and AB is the center of dilation. Sometimes the scale factor can be called other letters. I'm going to call it n in the next slide, so don't get confused by that. K is typically what we call the scale factor, but I'm going to use n just a little bit, so hopefully you don't get confused. So dilation is increasing or decreasing the size. Okay, so on this page, I'm going to call the scale factor n instead of k. This is a picture of a dilation. C is what we call the center of dilation. The N is the scale factor, and then P, Q, and R, P prime, Q prime, and R prime are the points of the two different triangles. So our center of dilation is right there. This is our pre-image. I'm going to write on top of it. And then this is our image. And so when you dilate, you transform it, and it has the following properties. So C, its image is C prime. When point R, for any other point R prime, no matter what you do, R prime is going to be on the line CR. And then CR is equal to the scale factor n times the length of CR. So, if I were to rearrange that equation, I would divide both sides by CR, and n is the scale factor of the length of CR divided by the length of CR prime divided by the length of CR. So n is going to usually be some kind of fraction, which a lot of times we turn it into a decimal. So like 1/4, we'll put it as 0.25. 1/2, we'll do 0.5. But sometimes we just leave it as a fraction, and then sometimes it can be a whole number. It just depends. When you dilate something, the angle measures will always stay the same. So R is going to have the same measure as R prime, P is going to have the same measure as P prime, and then Q is going to have the same measure as Q prime. The angle measures do not change when you dilate. What changes is the lengths of the sides. Okay, so here's a picture of a dilation that's centered at the origin. For a dilation that's centered at the origin, you can find its image of the point P, X, Y by multiplying the X and the Y, the coordinates of P, by the scale factor N or K, whatever the scale factor is. The coordinate rule for the dilation of a scale factor N or K with center of dilation at the origin can look like this. And you've seen the T before, so D would, let me change colors, would be a big D. Down here we would have a little n because that would be the scale factor, and then your original point xy, and that would be equal to your new point where you would multiply n by your original point, and that would be the rule that is used for the center or if the beginnings of the center of the origin. Okay, so here's an example. The question is the dilation of triangle XTR equal to triangle X prime, T prime, R prime an enlargement or a reduction? And what is the scale factor? So if you look, RTX or XTR is the smaller green one, and then X prime, R prime, or X prime, T prime, R prime is the larger one. So this is obviously an enlargement. And the scale factor, when we find it, we're going to use the ratio of the lengths of the corresponding sides to find the scale factor. Corresponding means they're in the same position. This is what is going to be very helpful to you when we do this, and you'll need to know this for later on in the year when we talk about congruent figures. The order of the letters is like a basically a way to kind of get like, I guess, cheat your way out of it, or like make sure you get it right. I should say. And so since X was first here and X was first here, they're corresponding. T and R and R. So side XT and side X prime T prime would go together as well, and so on and so forth. So when you do your scale factor, you're always going to do the image length, which is the largest one. So the image length is 4 plus 8, X prime T prime over XT. The image length is 12, and the pre-image length is 4. And so our scale factor is going to be 3. When you do the large image, or not always the large, but when you do the image on top, what's going to happen is if the image is smaller, then you're going to end up getting a fraction as your final answer, which is going to basically make it be a reduction. So always do the length of the image on top, because that is the only correct way to do it. All right, another example for you is how to find new vertices when you have a dilation. In this case, we have points Z, P, and G, and this is what are the vertices of the dilation with the scale factor of 2 of triangle PZG. I want you to bring a picture of this graph, both the original and the pre-image and the image. That needs to be brought to class completed. I'm going to check it in the very beginning of class, and if you did it, you'll get 100. If you didn't, you'll get a 0. So here's your class question to make sure that you bring, showing that you watched the video. So because the dilation is 2, that tells us that it's going to be an enlargement. So we're gonna go from a smaller to a bigger. And what you're gonna do, it's very simple. You're going to take your original points and you're going to multiply the x value and the y value by the scale factor. So P is 2, -1, so I'm going to multiply both of those by 2. Oops. So, goodness gracious. Let's try that again. Okay. So this is going to be 4, -2. Dilating point Z is going to be -2 times 2 and 1 times 2, which is going to give us -4, 2. And then dilating point G is going to be taking 0 and multiplying that by 2, and then taking -2 and multiplying that by 2. And so that's going to give us 0, -4. So you need to make sure that you graph these original points and graph the new points. Make sure you label them as P, Z, and G, and P prime, Z prime, G prime. And I'm going to check them at the beginning of class tomorrow. We'll do a few more dilation examples in class to make sure that you are understanding it. So be prepared to do an extra example or two, and we'll have a class discussion tomorrow just to kind of make sure everybody's on the same page, get any questions that you guys have answered, and then we'll do some practice of dilations tomorrow. So have a good night, and I'll see you guys tomorrow.